if there is any lamina is there, this one. So let this be the axis. I'll give a better diagram a little bit. Okay, let this be a lamina. Lamina, all of you, what do you mean with lamina? Any plain sheet of any arbitrary shape, like a disc, chapati, is called a laminar body. Notebook, thin notebook, or page, laminar body. A plain body, a plain object is called like a laminar object, that one. And strictly what all we discussed, perpendicular axis theorem is applicable only for laminar bodies. I'm making clear, laminar bodies, lamina. What are examples of laminar bodies like triangular plate, rectangular plate, semicircular plate, thin circular disc? It should be like a 2D object only. How the mass should lie in one specific plane only. So therefore I'm saying thin laminar body it is. Okay, now what about the axis? The axes are here, this one. So this is the x-axis. This is the y-axis. This will be the z-axis here. Now what he's saying is like for this particular no. This moment of inertia about laminar body. So in which plane the mass is distributed. This is very important. The mass of lamina is distributed in xz plane. Then according to this, the moment of inertia Iy is equal to Ix plus Iz. How to make a definition? The moment of inertia of a laminar body about an axis lying perpendicular to plane of lamina is equal to sum of moment of inertia of the rigid body about an axis tangential to the lamina or tangential to the plane of lamina, or about an axis lying in a plane of lamina. So definitely Ix and Iz, how they should be? They should be like about an axis where that axis is parallel to the plane or tangential to the plane, that one. So this is one condition is there. Then what about Iy? Iy is the mi of a rigid body about an axis. There's nothing called like a center of mass. No need of center of mass about an axis oriented perpendicular to plane of lamina is equal to sum of mi of rigid body about an axis lying in the plane of lamina. This is what the definition is saying. So the definitely there is any condition for Ix and Iz, they must lie in the plane of lamina. What about Iy? I must should be oriented perpendicular. And what about all these three axes must be mutually perpendicular. All these three axes must be mutually perpendicular. So there's a one more condition is what? It's putting here. All these three axes must be mutually perpendicular to each other. Get this one? So now let's, there's a definition. So let's generalize it. So let me make here. So now this the rigid body is there. Any arbitrary shape. Now in which plane it is lying? XY plane. So therefore now what is Iz? You can write it as Iz is equal to Ix plus Iy here. Because z-axis is what? The axis perpendicular to plane, that one. Previously, sir, like this ix and this one, this is another case. Sir. So don't take that this ix equal to that ix. It's a different rigid body, no? I'm just telling, look at the orientation of that one. So why not you write, sir, ix equal to iy plus iz? No. X and y axis are lying in the plane of lamina. Z axis is oriented perpendicular to plane of lamina. And any condition for its the intersection of axis, it must be at the center of mass. Need not center of mass. I can bring it here. You can see. And there's no rule that the three axes should intersect at the center of mass only. So it's all about the take the notebook, put it in different planes, then identify the axis which is perpendicular to the plane. Then the moment of inertia about axis perpendicular to plane of the rigid body, plane of lamina, is equal to sum of moment of inertia about an axis that are lying in the plane of lamina, or that are oriented along the plane of lamina. So this is what the perpendicular axis theorem it says here. Is it strictly applicable for laminar bodies only? We should not apply this for sphere, rhombus, cone, because they are not laminar bodies. All of you, cone, solid cone, hemisphere, hemispherical shell. So the perpendicular theorem is strictly applicable only for laminar bodies. The conditions they have put it here. And the point of intersection of axis need not lie at center of mass. So means I'll make it YZ plane. One more will take it. Now the body lies in which plane it is lying? Y. This is Z axis. So now the X axis will come in this direction. It's a rough diagram. I don't have, because 3D it will be very difficult to show that three-dimensional one. So this is, so now what is Ix? Ix, you should write it as Iy plus Iz, because where the lamina lies in YZ plane. So I think whenever you are applying perplexity theorem, first thing is what, like in which plane the mass is distributed. That is what you are supposed to accept. And all these three axes should be mutually perpendicular, and it need not be at the center. That's why I just put it here. So this is the center of mass. Let's come for this one. So we know many things. This we know about IOZ. No, I'll come for that one. Our main effort is for the torque equal to I alpha. I'm telling this one. This is it's just a mathematical based topic where a student should practice many numerical. That's all here. But the topic which we have to put effort is torque equal to I alpha. So I'm going to focus more on that. So this is about the x-axis, y-axis, the radius is r. Let m be the mass. For laminar body, the mass will lie in one given plane, specific plane. Example, notebook, paper, triangular plate. They are called like a laminar bodies. No, I want Ix and Iy. So we know IOZ. So what is IOZ? IOZ is equal to mr square by 2. I'll apply perpendicular axis theorem. And let's go for mi about x-axis. Is it distribution of mass about x-axis? Is it similar to that about y-axis? From symmetry of mass distribution. How the mass is distributed about x-axis. In the similar way, it is distributed about y-axis. So from symmetry, Ix is equal to Iy. What is x and y axis here? Shall I say that about diameter? So axis x dash will indicate. So what are x dash? A diameter. Okay, let's write the equation. So ix dash iox. Any reason for that? Because the mass is distributed symmetrically about xx dash and yy dash. So let me write, this is zz dash. So from the perpendicular axis theorem, ixx dash plus iyy dash. These two are equal, and we know izz dash mr square by 2. So this is the moment of inertia about any diameter. What is xx dash? About any diameter, no? Not on this, sir. I want moment of inertia about xy axis only. So shall I find out about any diameter? It's about because what is xx dash will become diameter, no? So perplexes theorem, sir. Like I don't like perplexes theorem. Then enjoy mathematics integration. So what is the main idea of this parallaxis perplexes theorem? To minimize the mathematics or to overcome the difficulties involved with the integration, because everyone will not be good in integration. Of course, you are learning integration, but but a person who is not having knowledge of integration, I think he will in a big trouble. No, you have to refer many books to conclude anything. Every time he has to struggle for a formula. So therefore, these theorems are brought to simplify the calculations involved with mi about different axes. That's the main purpose of this one. And the exam, definitely the professor will try to test you how you can apply these theorems in different situation. This is our primary motto here. Please keep this in mind. Okay, let's do one thing. So what all we studied, no? So if this is a circular disc, this one. So here, if this is the axis here, the axis is here. About any diameter it is. I think you can. What is moment of inertia about PP dash QQ dash, and this is a disk radius r. Will be same because about any diameter, no? But PP dash is equal to QQ dash, but they are not perpendicular. No? I think you should understand the things. PP dash is equal to QQ dash and is equal to how much? MR square by 4 about any diameter. And you should not apply PP dash is not perpendicular to QQ dash. So no question of perplexes theorem about that axis and that one. Able to make it out. So it's strictly what should be the axis. The axis, if you are applying perplex theorem, all three axes must be mutually perpendicular. This is a strict condition. Okay, now the same disk. The axis is tangential to this one. So I'll go for now which parallaxis theorem. So I want about axis PP dash. This is CC dash. So is this a perpendicular distance? Yes, definitely this is a perpendicular distance. No. So therefore, what is the moment of inertia about PP dash now? There's a different problem. IPP dash is equal to ICC dash plus M into perpendicular distance r square. What is ICC dash? Mr square by 4. Okay, there's a moment of inertia of the disk here. What is the axis? Tangential to the disk, that one. So perplexes theorem, parallaxes theorem. No, sir, I didn't like this. So what you should do now? About this axis, you must work out here, no? With the help of integration. I think this will be better, no? Better, let's focus more on parallaxes theorem, perplexes theorem. So that will be easy for us to get the answers immediately, that one. Okay, let me go for